Hi everyone, my name is Panu and welcome back to Space Everyday. Today we are going to learn about the International Space Station or the ISS. We will learn about its assembly, uses, orbit, etc. So let's get started. The International Space Station is a habitable structure made up of different modules orbiting about 400 kilometers above the Earth in a low Earth orbit or LEO. It is a multinational collaborative project involving 5 space agencies: NASA from the United States, Roscosmos from Russia, JAXA from Japan, ESA from 22 countries of Europe, and CSA from Canada. It is the largest artificial satellite in orbit. It orbits the Earth in around 90 minutes and completes about 16 orbits around the Earth every day. The station is divided into two parts: the Russian orbital segment operated by Russia and the United States orbital segment operated by the United States and the other countries. The space station consists of solar panels, habitation modules, radiators, docking ports, robotic arms, etc. Since the ISS is as big as a football field, specifically 109 meters long and 73 meters wide, it is impossible to launch it in one go even with current technology. So, the ISS was assembled part by part in space. Most of the Russian modules docked robotically, while the other modules were launched by the Space Shuttle and required installation by the Canadarm2 and the ISS or Space Shuttle crew performing EVAs or extravehicular activities. The first module of the ISS, Zarya, was launched in 1998 on a Russian Proton rocket. It provided propulsion, communications, electrical power, and attitude control. Attitude is not to be confused with altitude. Altitude means the height of an object, while attitude means the orientation of a spacecraft. 2 weeks later, NASA's Unity module was launched aboard the Space Shuttle. It has two pressurized docking adapters, one permanently for the Zarya and the other for the Space Shuttle when it had to dock with the ISS. In 2000, the Zvezda was launched into orbit. It had solar arrays which would provide power to the ISS. The Zvezda added a sleeping quarters, a toilet, kitchen, oxygen generators, etc. to the space station. The first crew, Expedition 1, arrived to the station in November 2000. The ISS continued to expand with the Space Shuttle delivering truss structures, the Destiny Laboratory, solar arrays, docking adapters, the Canadarm2, etc. As the station now had 3 sets of arrays, it could generate a lot more power. So more docking adapters and pressurized modules could be added. The Harmony module, also known as the Utility Hub, was added along with the Columbus European Laboratory. The station continued to expand with the Japanese Experiment module, the Russian Poisk and Razvet modules for docking, the last pressurized module of the USOS or United States Orbital Segment Leonardo, and several truss structures. By June 2011, the station consisted of 15 pressurized modules, 4 sets of solar arrays, a few laboratories, docking adapters, etc. Russia's latest research module, Nauka, docked to the space station in June 2021 along with the European robotic arm, which is basically like a human arm which has shoulders, elbows, and wrists. It is the first robot to be able to walk around the Russian segment of the ISS. Each permanent crew is given an expedition number. Expeditions mostly last for 6 months from launch to undocking. Expeditions 1 to 6 consisted of 3 members. Expeditions 7 to 12 were reduced to 2-member crews due to the failure of the NASA Space Shuttle Columbia. From Expedition 13, the crew gradually increased to 6 members around 2010. Now, due to commercial US vehicles being able to transport crew and cargo to the ISS, NASA has indicated that the expedition size may increase to 7, which the ISS was originally designed for. The ISS is currently in a circular orbit of around 400 kilometers. It travels at a speed of 28,000 kilometers per hour. It orbits the Earth at an inclination of 51.6 degrees to Earth's equator. This specific inclination was chosen because this was the lowest inclination that can be directly reached by the Soyuz spacecraft launched from Baikonur Cosmodrome in Kazakhstan without flying over China or dropping rocket stages in inhabited areas. Even though the ISS is in a fixed orbital inclination of 51.6 degrees, it passes over almost every place on the Earth. This is because while the ISS is rotating, the Earth is rotating below it as well. So, the start point and the end point of an orbit of the ISS are same in space, but not in maps which show the orbit of the ISS. Since the ISS is fairly low in altitude, atmospheric drag reduces the altitude of the ISS by about 2 kilometers every month. To raise the orbit again, the two main engines on the Zvezda module can be used, or it can also be done by Russian or European spacecraft docked to Zvezda. The Russian orbital segment contains the data management system which handles guidance, navigation, and control for the entire station. Yes, but also no. If country A knows that country B is going to deorbit the ISS beforehand, it might send more spacecraft from its side to counter that push by firing engines on that spacecraft. But as the ISS is a huge structure and the spacecraft are not docked opposite to each other, it might be risky as the ISS will spin. But if the country B deorbits the ISS without letting country A know anything, it might not be possible to save the ISS from an uncontrolled fall on almost any place on the earth, most of which is inhabited. But this is hugely unlikely as the countries have signed treaties and agreements. We will learn about the resupply of cargo, spacecraft which can dock with the ISS, and future plans of the ISS in the next part. That is it for today. Please like, share, and subscribe for more. Thank you.